Hello guys and welcome to my YouTube channel. In this video I will show you how to create a new project using Altium Designer and how to start adding components in schematic and to synchronize the schematic page with the PCB. So let's begin. For the first time we must go to the File tab, New, Project. We select the default project. We will call the project first Altium project. You can define the location, create project. After that, right click on the project PCB, add new to project, schematic. We will save the schematic with the name our first schematic. We go to add also the PCB file, add new to project the PCB. We will save the PCB, our first PCB. Okay, and now we will start to create the schematic for switching the grid from mils to millimeter. You only simply press Q key, and if Q key doesn't work, you can go directly to toggle units. But in general, this Q key works, but I don't know what happens right now. But we can check it in the PCB file. When we press Q, here the units were changed back to mils. Now hit key, millimeters, and the same thing here, or VU, VU, VU key. We have here the shortcuts, the V and U. For setting the grids, we can go directly here on this tab. To cycle snap grid, we must to press G key, and to set the snap grid, we can directly go here and define our grid. If we want to change the settings for the grids from line to dots, we will go directly here to preference, schematics, grids, and here we have line grid. So we will change to dot grid, and we can change also the color. We will set to black, And now you can see we have only dots. And now we have dots for our grid. In general, we use these settings for the schematic, the grid 100 mils for starting placing the components. We must to go on this tab, components, and in this case we have our two free libraries, one for the device and one for the connectors. So we will start with the connector libraries, and we need an header with two pins. We have here this header for zooming the page. You must to press Ctrl from the keyboard and using the scroll wheel, take the symbol and press X for mirroring. To mirror the symbol, simply press X. To rotate the symbol, easily press space. The symbol it's placed directly on the grid, on the snap points. In our case, we will put it here. We will put a name for the component P1. We will add the ground for this one. For creating a link between the ground symbol and the pin, you can go directly here to the place tab and select the wire, or simply press from the keyboard PW. We go directly to the snap point and we start to link together the pin number 2 and ground. For placing the power, we'll go directly here. We have this power point. We press it here. If we don't have available the symbol, we can exchange directly from here. If we want to be a bar, and the name for this it's VCC, so we can take it, rotate it with space, place it here, PW for connecting the wire with the pin. If you want to move it, you can take it only with the left click and move from here, or if you want you can move it like this. For the first component that will be placed, we will go directly to the device. We will take a regulator. We have this voltage regulator. We will place here the symbol. We will name it our voltage regulator 1. We will place the ground symbol. We will take some capacitors. I think I will take this 1206 footprint. If you want to move the name on the grid, this will always follow the grid, but if you want to move it to small points, please press the Ctrl key and move it directly where you want. Also the same for the name. So we will place here one. We can copy the symbol and place it here, the second one. In our case, this value is not the recommended one for this voltage regulator, so I will change it only for this demonstration. This is not a good way to exchange the values. You must to have one component for each value. So for this, it's important to create a new component, but for this demonstration, it's okay to modify here only the values. So we will copy this one, we will put it here, we will put this to one, and now we will create links for all of the components. This connected to this one, this connected to ground, this connected to ground, connected to ground, and this is connected to this point, this is connected to this point. So we want to put a name for this, C1, C2. We will go back to the components. We will search for a resistor. We have some values here, so we will take this 1K resistor. So for our circuit, we will put it here, resistor. Together with an LED. We have this one. This is the symbol for a normal LED. So we'll create a links place wire. So we will name it also the diode. And now we have our first schematic ready in Altium Designer. The next step to synchronize the schematic with the PCB and to have all the information from the schematic in our first PCB dock is to go directly to design and update the PCB. It's important to remove this ROM, or I will let it to show you what happens if this is present here or not. After that, you can validate everything is okay for our project, and we will execute the changes. Now all the information from the schematic page was bring here, and now we have all our components in this ROM. If you want to move some component, you can directly take it from this ROM, or you can select the ROM and delete it. Now we have to create the shape of our PCB, and for this we have few methods for define it. We can simply place some lines, one, to modify the orientation of the line. You must to press shift and space, and now we have this right angle, so we can draw it something like this. Hit left key from the mouse, and after that right click. We can select it, our drawing, go to design, board shape, and define from selected object. And this is our PCB shape. This is one way. If we want to move the origin here, we must go to edit, origin, and set our origin. We will go directly to the point where the origin will be placed, and we will select it here, this corner. If we want to create in another way the shape of our PCB, we can go directly here, board shape, and you have only limited options here, but we can let it for the moment like this, or we can switch it to another mode, hitting one key, and after that you have a lot of options here, and we can move or edit our board shape. We can redefine our board shape, and we have this rectangle, and we can exchange also the orientation hitting shift and space. and we we can go like this, and in the end right click, and now we can go back to the hitting 2 key to the normal mode, the 2D model. We can delete our previous lines, and we can move back the origin to the left corner. And now this is our shape. Because this shape is a little bit bigger for our PCB, we can again edit the board shape, hitting one key, go to the design tab and redefine board shape, and I will create a smaller version of this one. And this is our new shape. You can hit the 3 key from the keyboard to switch to the 3D mode, and with the help of the shift key and left click mouse we can shift and right click mouse we can move our PCB to look or to zoom in inside of this, and to switch back to the normal mode, the 2D mode, hit the 2 key, and now we will arrange our component to follow the link between the components. You can select it and go on the pad, press on the control key from the keyboard and check your connections. We will place the remaining components. To rotate a footprint inside of the PCB mode, hit the space key, the same like in the schematic editor. This is our resistor. So our PCB shape is a little bit bigger for these few components, but only for this demonstration it's okay. We can switch back to to this mode, hitting one key, and redefine the board shape to our needed. And now we can check a little bit how it looks. For some components we have 3D model, for some not. So now we place all of the components, so we will start to create tracks within the components. So this can be done in two ways. Go to place track and go directly on the starting points. To switching the orientation of the track, we must follow the same rule, hitting shift and space. To change the width of the tracks, hit the tab key, and in our case we have this width. We can exchange it to 0.5 or 1 millimeter. Or press P T from the keyboard and create also link between the components. As you can see, we have some violations here because our rules are not ready and are not defined properly. If you want to check what represents this violation, you can directly go over the track, select it, and press Shift and V key. And in this way, we can check it here what happens and which is the violations. So our violation says we have some width constraint. So for this, we will go directly to rules. So we'll define the routing width. In our case, we have the maximum of 0.25 and our track it's 1 millimeter. So we will define some minimum. Here it's the preferred and the maximum will be 2 millimeters. So now we will press OK and our violation disappear. To change the width of a track, we can go directly on this tab, select the track, right click and find similar object. In our case, our net that we want to change it's ground, so we will select it, the same net. All of our tracks with the same net are selected, so we'll go to the properties tab, and here we will tab, instead of 0.254, 1 millimeter. So now we have for the ground 1 millimeter for all of them. If we want to exchange only some parts from a track, we can directly select it and modify from here, or you can perform the same, find similar object, and we will exchange with 0.5. If we want to create a plane over the entire board, we will go directly on the place tab, we will select polygon, and we will define a polygon, hit shift and space always for changing orientation of the polygons, tracks, lines. If we want to define the net of this plane, we will select here ground, and after that we'll go to the tools tab, polygon pores, and we pour all. And now we have a ground plane created for our PCB. If we want to place a via here for one ground point, hit PV, and we will place here a via or more via here. To change the parameters of a via, hit the tab key, and here we have the diameter of the via and the hole size. In general, for this via, I used the hole size 0.4 and diameter 0.7. Depends on the project. So I will place this new via here. You can see the dimension of these two via are different, so we have some violations here for the via now. So we must go to the design rules and locate the via. So we have here the routing via, and we have some default values here defined, and we must exchange to achieve our values. So for the via hole size, we will put here 0.3, 0.4, and the maximum 0.5. And for the diameter, we will put here the minimum 0.6, the preferred 0.7, and the maximum 0.8. Hit the OK button, and now all the violation disappear. So we have some violation for the others one. So we will select the via using the same command, find similar object for all via. Okay, we will check here. The whole size will be 0.4 and the diameter will be 0.7. So now everything is okay and we don't have any other violations. So we can check again how it looks from the 3D side, and we can rotate it using shift and right click from the mouse. We can check also some conflicts and if our PCB looks okay. If we want to put in the correct position, here we must to hit VF to fit our PCB, and now it looks more better. To switching back to the normal mode, we will hit the 2 key, and now we have ready our first PCB project together with our first schematic, and we receive some news information for creating a new project. And in the next video I will present you how to continue with this file to create the manufacturing files or to create new components and to put the missing 3D models. I hope this information is very helpful for the beginners engineers and also for the students, and I hope we will meet together here in the next videos, and I wish you all the best and see you soon in the next video. Bye bye.